going to show you how to find the empirical formula of a compound. Before we get started, let's talk about what an empirical formula is really quickly. So molecular formula is what we're used to seeing. And the empirical formula is actually what I call just like the simplified version of the molecular formula. Just like you would simplify a fraction, formulas simplify also. So if we have C6H12O6 as our molecular formula, what we notice is that those subscripts can all be divided by 6. And if we do that, the empirical formula is going to end up being CH2O. So it's really just the more simplified version of the molecular formula. And we can figure this out if we're given a percent composition of the compound, and the way that we do that is with these steps, and it kind of rhymes, so it's like a little poem that you can memorize, and that'll help you remember the steps to figure these out. So here's the poem: percent to mass, mass to mole, divide by small, multiply till whole. So those are our 4 steps that we have to do to get to our empirical formula, and so I'm just going to work one out so that you can see how those steps work. So here's our question. A compound is found to be 1.8% hydrogen, 56.1% sulfur, and 42.1% oxygen. What is the empirical formula of this compound? So what we're going to do is work out 3 separate problems, one for hydrogen, one for sulfur, and one for oxygen. And we have to do all 4 steps for all 3 of those elements. So let's just start with the first step, which is percent to mass. For percent to mass, we're literally just going to take that percentage and turn it into grams. We don't even have to do any kind of calculating or anything. Just take that percentage and turn it into grams. So for hydrogen, that 1.8% is going to become 1.8 grams of hydrogen. For sulfur, that 56.1% is going to become 56.1 grams of sulfur. And for oxygen, that 42.1% oxygen is going to become 42.1 grams of oxygen. And that is our entire first step. The second step is mass to mole. So mass to mole, what we're going to do is convert our grams to moles. So that is going to require a T-chart, always going to be a T-chart. So I'm just going to take the numbers that we've already written and turn those into our T-charts. So we know that this is our given for each of these 3. And we're going to go through our normal steps like we would. If we're converting to moles, we're going to put moles on top because that's our goal unit. And we know that we need grams on the bottom so that our units will cancel out. So all the way down, we're going to have grams on bottom and moles on top. And so since we need to know to get from grams to moles, that means we're going to need our molar mass. So for this step, we do have to use our molar mass of these elements. So for hydrogen, let's go ahead and look up hydrogen's molar mass. So hydrogen's molar mass is 1.008. So I'm going to fill that in to my T-chart, 1.008 grams in 1 mole. Let's go ahead and look up sulfur. Sulfur is 32.07. So 32.07 grams in 1 mole. And last but not least, oxygen is 16.0. So oxygen is going to be 16.0 grams in 1 mole. So our T-charts are set up. We just have to do our calculations. So what I'm going to do is multiply across the top and divide by the bottom. So what you're going to actually end up doing for this step is always dividing by the molar mass. So 1.8 divided by 1.008 is going to give us 1.79. It's good to go to about 2 decimal places when you're rounding for these. Try to be as accurate as possible. If you want to go 3 or 4, that's even better. I'm going to stick with 2, but we have 1.79 moles of hydrogen at this point. For this next one, 56.1 divided by 32.07 gives us 1.75 moles of sulfur. And lastly, 42.1 divided by 16.0 is going to give us 2.63 moles of oxygen. Okay, so we have completed the second step, which is mass to mole. We have calculated all of our moles of these substances. So the third step is divide by small. We're literally, for this step, just going to divide by the smallest number. And we have to do that for all three. Okay, so let's look at our numbers we have. 1.79, 1.75, and 2.63. So we're just going to pick the smallest one and divide all three of those numbers by that same number. So it looks like 1.75 is our smallest. So we're going to take all three of those numbers and divide by 1.75. So 1.79 divided by 1.75. When I type that in my calculator, I get 1.02. For my next one, 1.75 divided by 1.75 is just going to give us 1. And then for my last one, I have 2.63 divided by 1.75. And that's going to give me 1.5. Okay, so right now we have 1.02, 1, and 1.5 at the end of our divide by small. So the last step, I'm going to zoom in a little bit for this one, is multiply till whole. So this one is kind of optional. So for this one, we may not be necessary. So at this point, if you already have whole numbers, so by whole we mean whole numbers, okay, so 1, 2, 3, 4, no decimals. So at this point, it's possible that you could already have whole numbers. And I also want to note that if it's close enough to a whole number, we can round that off. 1.02, that's really, really close to 1. That is pretty much the same thing as saying 1. What's not okay is 1.5. 1.3, 1.4, 1.5, even 1.2. Those are just not really close enough in my opinion. If you're 0.1 or 0.9, something really close to a whole number, we can round that off. But 1.5 is not a whole number. So what we're going to do is we're going to multiply these numbers until we have a whole number. So this works just like in math, where if you do something to one thing, you have to do the same thing to all the rest of them. So we're essentially taking all three of these numbers and we have to multiply them by something to get a whole number. So if we have 1.5, I'm going to look at that 1.5 and say, well, if I multiply that by 2, then that's going to give me 3, right? So that's a whole number. So what I can do is actually multiply the rest of my numbers by 2 also. And so what I get is 2. 1 times 2 is 2. 1 times 2 is 2. And 3. So these are our final numbers after the end of step 4. After we've multiplied till whole, we get 2, 2, and 3. So remember that 2 is telling us about hydrogen, this 2 is telling us about sulfur, and this 3 is telling us about oxygen. So what that's telling us is in our final empirical formula, we need to have 2 hydrogens, we need to have 2 sulfurs, and we need to have 3 oxygens. So we're going to write that out like we would in a chemical formula, which is with subscripts. So our empirical formula would be H2, S2O3. Okay, and that is the answer. So percent to mass, mass to mole, divide by small, multiply till whole. And then we take those whole numbers and turn them into subscripts to give us our final chemical formula.